if n minus 1 number of main scale divisions of a measuring instrument is divided to n number of Vernier scale divisions, it means higher number of Vernier scale divisions, then the least count of the instrument in main scale division is. So they are asking for the least count of the measuring instrument. Okay, so to find the least count, we have this equation: least count is equal to length of one main scale division. Length of one main scale division minus length of one Vernier scale division. So here, let's say length of one main scale division is, length of as 1. Then we have to find the length of Vernier scale division. So here we are using n minus 1 number of divisions in the main scale. So the length we are using here of the main scale should be n minus 1 times 1. That is the total length of main scale that we are using here. So for the Vernier scale, that length n minus 1 times 1 length is divided into n parts. So this whole length is n minus 1 times 1. It is divided n times in the Vernier scale. So the length of one Vernier scale, one division of Vernier scale, length of one division of Vernier scale should be n minus 1 times 1. It is divided into n parts. N minus 1 times 1 divided by n. So n minus 1 times 1 divided by simple n. So this thing is going to be the least count here. So it is 1 minus n minus 1 divided by n. Common denominator is simple n. N minus 1, n minus n plus 1 divided by simple n. So this is going to be 1 over n. So this is the least count of the Vernier caliper. That is the measuring instrument. Okay, moving on to the second question. Energy of a photon is given by E equals hf. H is the Planck constant and f is the frequency of the light. So they are asking for the possible unit of h, which is the Planck constant. They are asking the units of Planck's constant. So here we have the equation. E equals hf. Energy, Planck constant, and this is frequency. So you have to remember that the equation for the frequency. So we know that for the frequency it is 1 over time period. So the units of frequency should be 1 over time. So it should be per second. Units of frequency is per second. Then you just have to substitute those units in the equation. So energy, you should remember, so energy is measured in joules. So H, Planck constant, then F, that is the frequency. It is measured in per second. So then you have to subject simple H, that is the Planck constant. So if you subject that, it becomes joules second. So joules second is the unit of Planck's constant. So here you have to remember when you study units and dimensions, the units of energy and the units of frequency. So equation for frequency is 1 over time period. Time is measured in seconds. So 1 over second is becomes per second. So per second is the per second, or there's another unit called hertz. But here we are using per second. So the units of per second, this is the unit. Then you just have to substitute those units in the equation. Then you can find the units of the Planck's constant. Okay, the third question. Time period of a simple harmonic motion is given by the equation below. If G has dimensions m minus L3 d minus 2, they are asking physical quantity of d could be. So here you just have to substitute the dimensions in the equation. So this is the equation. T equals 2 pi 1 over g d root. So the dimensions of the equation also should be the same. 2 pi does not have dimensions. This is just a number, so it doesn't have dimension. It's not. So we are getting rid of that. Then dimensions of 1 over gd root. So for the time period, the dimension also is capital T. So then dimensions of G is given here. You just have to substitute those. So that's going to be m minus 1 L3 T minus 2. Then this is just D. The dimensions of D, we'll find the dimensions of D. And this is the root. This is the root. In order to simplify this, I'm going to square both sides of the equation. So d square is equal to 1 over m minus 1 L3 t minus 2 d. Then I have subject simple d. I'm cross multiplying, so t square goes to the denominator. M minus 1 L3 t minus 2 t squared. Then t square t minus 2 cancels off. So we get dimensions of t as 1 over m minus 1 L cube, like that. T square gets cancelled off here. The dimensions is equal, you can take this to the numerator, then it becomes m L minus 3. So if you remember, m L minus 3, that is the dimensions of density, right? So the density is mass divided by volume. So it is mass divided by volume. That's the dimensions of the density. So the answer should be the third one. Okay, fourth question. A bat flies towards a vertical wall inside a den at 30 meters per second. So let's say this is the bat flying towards the wall. Speed of the bat is 30 meters per second. That is the speed of the bat. It makes a sound when the distance between it and the wall is 3 meters. So we are considering that instant. So at that instant, the distance between the bat and the wall is 3 meters. If the speed of sound in air is 330 meters per second, distance that bat moved towards the wall as it hears the reflected sound wave is. So here the bat makes a sound. The speed of sound is 330 meters per second. That is a constant speed. So you can consider that sound moves like that, like it moves towards the wall at 330 meters, then reflects off the wall and moves towards the bat. So Simultaneously, the bat also moves towards the wall. So they are asking the distance the bat moves as the bat would hear the sound. Let's say the bat moves towards the wall, distance d. So while the bat moves the d distance, the sound has moved from here, then reflects off the wall, then comes back to the bat. So the bat would hear the sound. Okay, so the bat moves a d distance, sound reflects off the wall and comes back to the bat. So using this data, we have to build an equation. There are many ways you can do that. So we need to get a common point for the bat and the sound. Since both cases are causing simultaneously, we can find the time for the sound wave to move from here to here. So I'm using S equals ut. So the total distance that sound wave moved is, this distance is 3 meters. Then this distance, I can say that distance to be 3 minus d. Because 3 meters is from here to here, then this is d, then this should be 3 minus d. So the total distance that sound moves is 3 meters plus 3 minus d. 3 plus 3 minus d. So that is the total distance that sound moves from here to here. Then just divide it by the speed of the sound. Then you get the time required for the sound to move from here to here, here to here. Then I'm going to find the time required for the bat to move from here to here. So the distance that bat moves is d, very simple d, should be divided by the speed of the bat. So the speed of the bat is given as 30 meters per second. Since both cases happen simultaneously, Ts is equal to Tb. So the time spent by the sound is equal to time spent by the bat. So you just have to substitute these values. Tb, that is d over 30. Results of 1, 11, then 6 minus d equals, I'm cross multiplying, 11d. Then put d to this side, then 6 equal to d plus 11d. 12d equals 6. Then d equals 6 divided by 12. It is half. So the distance that bat moved is equal to 0.5 meters. So as the bat moves a distance 0.5 meter, echo of its sound would be heard by the bat. Okay, the fifth question. A mango falls from top of a tree. So I'll draw the tree. So let's say this is a tree. So what we have to do is to find the height of the tree. Let's say the height of the tree has a capital H. Then there's a window. And the height of the window is 2.4 meters. The mango takes 0.4 seconds to pass the window. The mango takes 0.4 seconds to pass this window. So someone inside the house would see the mango through the window. So if we measures the time it took for the mango to pass the window, that time is 0.4 seconds. Then they have given from the ground height to top edge of the window is 3 meters. So those are the data. Then they are asking for the height of the tree. So let's say this is the mango tree. So if this height is 3 meters, I can say that this height is 3 h minus 3. This is capital H. The total height is capital H. Since this is 3 meters, this height is h minus 3. Okay. So the mango falls under gravitational acceleration. So it is 10 meters per square second. So let's say the mango takes simple t amount of time to move from here to here, meaning from the tree to the top of the window. Let's say the mango takes a simple t time. Since the time is spent for the mango to move this distance is 0.4 seconds, this time should be t plus 0.4. This time is, if this is simple t, so this time is t plus 0.4. Then I can apply the equations, motion equations from here to here. So first I'm going to apply v equals u plus 18. The initial of the mango, that is in the tree, so the initial speed is 0 plus this distance is 10, acceleration of the mango is 10, then the time is spent is t. So I can say the speed of the mango here is 10 t. Then by applying the same equation from here to here now, still initial speed is 0 for the mango, acceleration is 10, but the time is spent is t plus 0.4. So this is the speed of the mango at the bottom edge of the window, 10 t plus 0.4. Okay, now we know the speeds of the mango at the top and bottom edge of the window in terms of time. Then I am going to use this equation. S equals u plus v divided by 2 times t. So I am applying this equation from here to here within the distance of the window. So the speed here is 10 t. The speed here is 10 times t plus 0.4 divided by 2, then multiply it by simple t. Not simple t here because we know that they have given the time for the mango to pass the window. The time is 0.4 seconds. It is given. So you just have to multiply that by 0.4. 0.4. And the distance, I mean, that's going to be height of the window. That is 2.4. Okay, then you have to just simplify that. You can cancel these two like 0.2, then 0.21, then this is 12. So then 12 equals 10t plus 10t plus 4. Then subtract. So this is 8 equals 20t. Then the time is equal to 8 divided by 20 for 10. So it is 0.4 seconds. So now we found the time is equal to t. That is for the mango to move from here to here. The time required for the mango to move from here to here is 0.4 seconds. Okay. So if you know the time, then I am going to apply S equal ut plus half ad squared from here to here. So initial speed, that is 0 for the mango. So this is 0 plus half acceleration 10. T squared, we found t squared, that is 0.4. 0.4 squared. Then this whole thing is equal to what? H minus 3. That is the distance traveled here, from here to here. Okay, h minus 3, that is equal to half 10. 0.4 squared is 0.16. So if you divide it 0.08, just have multiply by 10, then h minus 3 is equal to 8. Sorry, 0.8. 0.8. Then h is equal to, put 3 to the other side, 3 plus 0.8, that is 3.8 meters. So this is the height of the mango tree, 3.8 meters. So the answer there is first option, that is the answer. That is the height of the mango tree. Okay, next question, 6. Maximum height that an object reaches when it is projected with an initial velocity u, which makes an angle theta with horizontal is. So this is a question about projectiles. If you remember that, so they are asking for the maximum height of a projectile. So the initial speed of the projectile u, it makes a theta angle with the horizontal. So the projectile motion of that gets a shape like this. Gravitational acceleration, you can take it as simple g downwards. So those are all the data. They are asking for the maximum height that the object reaches. So this is the maximum height. I say that maximum height as capital H. So this is a simple question. All you have to do is just apply v squared u squared plus 2as upwards, vertically upwards. So here you are only considering vertical components, right? So you just have to substitute all those vertical components. So the vertical component of speed is u sin theta, and the horizontal component is u cos theta. That is for the initial speed. This is the vertical initial vertical component of the initial speed, that is going to be u sin theta. Then we know that at the top, as it reaches here, the vertical component of the speed is 0, of velocity is 0. So I am applying equation, this is an equation from here to here. So here we have the, so final velocity, that is 0, at the top, that is 0. Then u squared, that is u sin theta squared, plus 2, acceleration is downwards. Since I applied the equation upwards, I am putting minus g here. Then the distance it traveled is capital H. Then you just have subject capital H. I'll take this term to this side, then 2g capital H equals u squared sine squared theta. Then capital H is equal to u squared sine squared theta divided by 2g. So this is the maximum height of the projectile. So the answer should be second one, right? That is u squared sine squared theta divided by 2g. Okay, the next question, seventh one. An object has two inclined velocities. Resultant velocity of the object is perpendicular to one of the velocities. So let's say these are the two velocities, P and Q. So if these are the two velocities, the resultant vector should go between P and Q. It should be between P and Q. It should be like this. So this is the resultant velocity vector. Then they say that one of the velocity is perpendicular to the resultant velocity. So if one velocity is P, then the resultant is perpendicular to one of that. I'm saying that velocity, I take that as P. Then the other velocity vector should be to this direction, right? Because the resultant should go in between those two velocities, P and Q. So let's say that Q vector is like this. Then using these, so this is the only way that this could happen. If the resultant should be normal to one of the velocities, this is the only way that could happen. So the angle between the vectors, velocity vectors, is obtuse, as you can see. Then I'm going to draw a parallelogram. Then I can explain which velocity is bigger. So how can you draw a parallelogram? So what I have to do is I just have to draw a line parallel to Q, which goes through this point. So let's say that this is a parallel line. Then draw another parallel line to P, which goes through this point. Okay. So this is parallel to Q and this line is parallel to P. Okay. So the options given are resultant is perpendicular to small velocity. So by looking at this, you should be able to say that this P should be the smaller one. This Q is the hypotenuse of these two. This one is equal to length P. This also is P. And this is R. Then Q should be the hypotenuse those two. So Q is the bigger one. P is the smaller one. P is not the hypotenuse. It is just one side of the triangle. So they say that resultant is perpendicular to the small velocity. So it is correct. This is the resultant and this is the smaller velocity. This is the small, this is the bigger one, right? So A is correct. Then B, result is perpendicular to B. It is not perpendicular, right? Between resultant and Q it is an acute angle. It is not perpendicular. Cannot be perpendicular, it is not possible. Right? Then other one is angle between the two velocities should be obtuse. So it is obvious that C also is correct. Between P and Q, the angle is obtuse. Yeah. So the answer should be A and C. So the answer should be the first one. Okay. Next question. 8. A monkey weighing 20 kg is hanging by a rope. So let's say this is a rope. And there's this monkey. This is the monkey. Then the weight of the monkey, the mass is 20, so the weight of the monkey should be 200 newtons. That is the weight of the monkey. Given that maximum weight rope can withhold is 25 kg without breaking it, maximum acceleration that the monkey can move upwards along the rope is. So here the monkey is moving along the rope, holding on to it. So they are asking the maximum acceleration that the monkey can move along the rope. So the rope would not break. So if it is a maximum acceleration, so that should be the maximum tension of the rope. So then they say that maximum weight the rope can withhold is 25 kg, is 250 Newton of tension can be withheld by the rope. So this is the maximum tension that the rope can withhold. That is 250. So you have to understand that. Okay, that this 250 is on the monkey. Then what we have to do is just apply F equals ma to the monkey. To monkey. F equals ma. So tension on the monkey, that is 250 upwards. Downwards, the weight of the monkey, that is 200. That is equal to mass of the monkey is 20. Then the acceleration, that is the maximum acceleration that the monkey can move along the rope, holding it. So this is 50 equals 20a. 0, 0 cancels off. Then a max is 5/2, which is equal to 2.5 meters per square second. So this is the maximum acceleration. Maximum acceleration that the monkey can move along the rope, holding on to it. So the answer should be the first one. The answer for the 8th question, that is first one, 2.5 meters per square second. Okay, next one, 9th question. A balloon with total weight, simple W, falls at an acceleration, simple A, then the acceleration is less than gravitational acceleration. So you have this balloon. They say that it moves down with acceleration simple A, and this A is less than gravitational acceleration. So that acceleration could be something like 5, it should be less than 10. Then the weight of the balloon, they say that it is W. Then there's an upthrust acting on the balloon by the air as well. So this is the first case. Then they say some weight from the balloon is removed. Then the balloon moves upwards with acceleration simple A. So when some of the weight from the balloon is removed, now the balloon is lighter, it moves upwards now. For the first case, it was moving downwards. Now it is moving upwards at the same acceleration. So what they ask is to find the weight of material to be removed in order for that to happen. Let's say removed amount is removed weight. I'm taking that as W dash. So this W dash is what we need to find. Okay, I'm drawing that for the second case. If a W dash of weight is removed, now the weight of the balloon is W minus W dash. Since W dash is removed from the balloon, they say that the upthrust does not change. Then the upthrust is simple U, upwards. Okay, now this is moving downwards. Here it's moving upwards at simple A. So this is the first case. Then we have the second case. Okay, now separately we have to apply F equals ma to these cases in order to find this W dash. Let's see how to do that. Okay, first time applying for this case, upwards F equals ma. Then we have U, upwards U, that is upthrust, minus weight equals mass of this balloon. This W is the weight of the balloon, right? That is like mg. W is equal to mg. So the mass of it's like W equals mg. So the mass is should be W over g. You have subject mass, right? So you cannot put weight here. So you have to divide weight by gravitational acceleration in order to make that the mass of the balloon. And this is acceleration, that is down, that is up. That is now you have to apply the equation downwards, right? Because the balloon is moving downwards. We can apply like upwards as well, but it would be confusing. Okay, it doesn't matter. We'll just apply the equation upwards. It does not matter, right? All you have to do is make this acceleration upwards. So the acceleration upwards is minus a, right? It doesn't matter. Then again, so this is the equation for the first case. U minus W, this one. Then I'm applying equation for this one. F equals ma. So upthrust upwards, then downwards is W minus W dash. That is the weight, net weight of the balloon. Then that is equal to, now the mass of the balloon is W minus W dash. You have to divide that by G. In order to make that a mass, this is the weight of the balloon, you have to divide it by gravitational acceleration to make it a mass. That's the mass of the balloon now. Also now this is simple A. Because acceleration is upwards, I'm applying the equation upwards. So here also acceleration is positive, but here you substitute it as negative acceleration. It does not matter, right? So if it is to the other side, you just have to put a negative there. Here you have to put a positive there. Okay. So this is the second equation. Then I am going to subtract this equation from first equation, then second equation. So if I subtract that first equation, that is U minus W minus that whole thing, U minus W dash. So I subtracted the left side, then I have subtracted the right side, that is WG minus A minus W dash G simple A. Then as you can see that this U and this U, this plus U minus U cancels off. Minus W, then multiply this with a minus 1 inside of the brackets. This is going to be plus W minus W dash equals, this is minus W A over G minus, then multiply by minus 1 minus, no, I'll just keep it like that, W dash divided by G multiplied by A. So in this equation you just have to subject W dash. That's all you have to do. After that, this is just a simple calculation. So the answer for this one, let's see, like this one and this one cancels out, minus plus. Then you have here minus W dash equals minus W A over G minus W A over G plus W dash A over G. So this is what you would have there. Okay, I'm taking this part to here. So we have minus W equals, this is minus 2WA divided by G plus WA over G. I'm taking this to this side, W dash plus W dash A over G, and this term to the other side, so it becomes positive. 2WA over G. So I can take W dash out, so this becomes 1 plus A over G, 2WA over G, W dash G plus A, denominator is simple G, 2WA over G, GG cancels off, then W dash is equal to 2WA divided by G plus A. So this is the answer there. So after this one, it is just a simple calculation. You just have a subject G dash, W dash. It's a simple calculation. So the answer should be fourth one. Okay, 10th question. A trolley moves on a smooth horizontal plane under a constant horizontal force, capital F. So there's this trolley. It is moving in a smooth flow, so there's no friction. So the force acting on the trolley is capital F, which is constant. And they have given the total mass of the trolley. Given the rate of sand leaking the trolley is M. So M is a rate, right? Remember that? That is a rate of sand moving out of the trolley. It could be like 2 kilograms per second, 3 kilograms per second. It is a rate, right? Simply, it is a rate. They are asking acceleration of the trolley after time period simple t. Okay. So we have to find the mass. So if the sand is moving out of the trolley is losing its mass. If the rate of mass moving off the trolley is simple m, mt, after a simple t time, the amount of mass removed of the trolley should be mt, m times simple t. Let's say like if the rate is 2 kilograms per second. Per second, 2 kilograms of sand is removed, for an example, right? So you just have to, let's say for 5 seconds, after 5 seconds, how much sand is removed. So you just have to multiply the rate by the time, then you can get the amount of sand removed. So here as well, after t time, we know the mass of trolley should be, so mt amount is removed, so the mass of the trolley should be m minus mt. Okay, so they are asking for the acceleration, right? At this instant, they are asking for the acceleration at this t instant. So all the force is a constant, right? It does not change. They say that it does not change. So you just have to apply F equals ma to this instant. So the force is capital F. Mass of the trolley now is capital M minus mt. Mt means this is a rate, right? So this, when you multiply that by time, it becomes a mass. M minus mt, then acceleration. Then you just have to subject acceleration. So that should be F divided by capital M minus mt. That is the acceleration at this instant. Okay, so the answer should be second one, right? second one should be the answer, that is F divided by capital M minus MT. Okay, next one we have a graph here. Image shows a VT graph for the downward movement of a lift weighing 500 kilograms. Tension of the cable when T equals 7 seconds is. So we have a lift. The weight of the lift is 500 kilograms. Sorry, the mass of the lift is 500. So then the weight of the lift is 5000 newtons. Then for the motion of this lift, they say that it's moving downwards. For the motion of the lift, they have given a VT graph. So it is moving downwards. So at this part, we can say that it is moving downwards at an acceleration. Then at a constant velocity, then it decelerates, moving downwards, right? So this when T equals 7, the time is somewhere here. T equals 7 is here, right? When T equals 7, the lift is decelerating. So within that time period, the deceleration is a constant because this is a linear. This deceleration is constant. So we have to find the deceleration at this part. So to find the deceleration, that deceleration we know that is equal to the gradient. So we have to find the gradient of this part. That is going to be equal to the deceleration of the lift. So this is 6, 8 and this value is 2. So this height, we can say that this height is 2. Then this length along the time axis is 8 minus 6, that also is 2. Then the gradient is equal to 2 divided by 6 minus 8. Y coordinates divided by x coordinates. The differences of coordinates. So the answer should be 1 ms minus 2. So that's the gradient of this graph. But downwards, there is a negative acceleration because here is a decelerating, right? It is moving downwards, but it is a deceleration. It is decelerating but moving downwards. Okay, then we have to apply that there's a tension. To control the motion of the lift, we have this tension. Then you just have to apply Newton's laws. I'll apply Newton's laws downwards. It doesn't matter which direction you apply, as long as you substitute correct sign there, whether it is negative or positive. So downwards, so the weight is 5000 with the tension upwards, capital T. This is equal to mass 500 times acceleration. Actually, it is a negative acceleration. You have to put a minus 1 here. Because to downwards it's a negative, right? To downwards it's decelerating. Then I'm subjecting T. So this is minus 500. I'm taking to the other side, it becomes plus 500. Then the tension is 5500 Newton. So this is the tension when it is decelerating. Okay. So you can find. So this is what they ask, tension when it is decelerating. So the answer should be 5500 is the first one. First one is the answer. So if they ask the tension when it is at constant velocity or when it is accelerating downwards, you just have to figure out the acceleration in each part. Then just apply F equals ma to that particular instant. So that is what you have to do if they ask for that as well. Okay, next question. A uniform rod with length capital L placed on a smooth table is applied forces F1 and F2 to ends of the rod. So we have this rod on a smooth plane. So there's no friction acting on the rod, right? It is on a smooth plane. Forces F1 and F2. F1 and F2. They say that F1 is larger. So the acceleration of the rod should be to this side. F1 is larger. So those forces are applied. Those are the only forces acting on the rod. Then they are asking tension at a distance y from the end that the F1 force applied is. So this is the point F1 force is applied. Then they are asking the tension at a distance y. So when they ask something like that, it's better to like imagine a separation between, at that point, right? So they're asking, okay. So let's say we separate this one from here at this point. Just imagine that. We are not actually separating it. Just imagine there's a separation. Then at this part, the tension acting is towards here. This tension is applied by this part, on this part. These are action and reaction forces. Then on this part, the tension acting by this one is to the other side. That also is T. Those are action and reaction forces. So, okay. Then to whole rod, you just have to apply F equals ma to the whole rod. This is to find the acceleration first. So if we consider the whole rod, the system here on the rod, these forces are not applied, right? T and T, these are internal forces. So if we think about the whole rod, the external forces are F1 and F2 only, right? So when we apply that one, F equals ma to this side, force is F1 minus F2 equals to the whole rod, let's say the mass of the rod. I'm saying the mass of the rod as simple m. Let's say the mass of the rod is simple m. Simple m times acceleration. So acceleration is equal to F1 minus F2 divided by mass of the rod. So now we know the acceleration of the system. Okay, this is first you have to find this one. Then that is not what they ask. They are asking for the tension here. Then I'm applying F equals ma to this part only. Only for this part, right? Only for that part. So what are the forces acting on this part? One force, F1 is acting on that part. Then there's this T to the other side, right? This T is acting on this part, but the other T is acting on that part. So F1 minus T is equal to, now the mass of the rod. I'm not going to substitute simple m here. You have to get mass of this part only, right? So if the total length of the rod is capital L, the mass of this part only, I can write it as a fraction. If the mass of the whole rod is simple m, you can multiply that by y, then divide it by the total length. Y divided by the total length, that's a fraction of the rod. Then multiply that by the mass of the total rod, whole rod. Then you get mass of this part only. So that is my divided by L. Then for that part as well, the acceleration should be simple A. Okay. So what we need to find is this capital T, right? Earlier we found an expression for simple A. So I'm substituting that one here. So for simple A, I can substitute this one. That is F1 minus F2 divided by simple A. Then this simple m and this simple m cancels off. Then F1 minus T equals y divided by L. F1 minus F2. Then I am subjecting capital T. F1 minus y over L. F1 minus F2, that is equal to capital T. That's equal to capital T. Okay, then let's see how to get an expression for that. I have to separate F1. I have to take F1 out. So I'm multiplying by this term y divided by L F1 minus minus plus y F2 divided by L, that is equal to T. Then from these two terms I can take F1 out. So if I take F1 out, it is 1 minus y over L plus F2 y over L, that is equal to T. So this is the answer. So the answer should be F1 1 minus y over L plus F2 y over L equals tension. So the answer should be the first one, right? Answer should be the first one. So in this question, all you have to get, you should have like that understanding of internal and external forces. So if we consider the whole rod, the external forces are F1 and F2. But if we consider only this part, the forces are F1 and this T. Those are the external force on this part. So you have to know that term. You have to understand that. Okay, then 13th question. Two masses, capital M and simple m, are placed on a smooth plane and forces F and simple f are applied as shown by the image. Normal reaction force between the masses is. So the image is given. One mass capital M, another one simple m. The forces capital F and simple f are applied on the system. So they are asking normal reaction force between those two masses. Let's say the normal reaction between the masses is P. And these are the action and reaction forces. This P is applied on simple m. This P is applied on capital M by simple m. So those are the action reaction forces. They are asking for simple P. So for this one as well, you just have to apply Newton's laws. First, I'll apply Newton's laws to the system. So when we consider the system, these becomes internal forces. Those are cancels off, right? So when you think of the whole system, the external forces are F and simple f. This side, F minus simple f equals ma. Let's say the acceleration is simple v. Then I'm subjecting simple f, that is F minus simple f divided by, the mass is simple m plus capital M, simple a. Then F minus f divided by simple f plus capital M. This is the acceleration of the system. So if we need to find P, you need to apply F equals ma only to this part, simple m. You can find using this by applying that to capital M as well, but it is easier to apply for this one, simple m. So if you apply it F equals ma to simple m, so the force is acting now. For simple m, P is external force. So to this side there's P, then to the other side there's simple f. So the resultant force on simple m is P minus f. And the mass is simple m and the acceleration. is simple A. For that one also acceleration is simple A. So P is equal to F plus simple ma. What you need to find is P. Then just substitute this simple A there. F minus simple F divided by simple M plus capital M. The common denominator is simple M capital M. Just multiply that by simple M plus capital M plus M capital F minus M simple F. As you can see, this plus Fm and minus Fm cancels off. So what you get is simple F capital M plus simple M capital F divided by simple M plus capital M. Okay, so this is the normal reaction between the masses, capital M and simple M. So the answer for that one should be the third one. Then 14th question. When horizontal force capital F is applied on M1, normal reaction force between M1 and M2 is, they say that plane is smooth, so there's no friction involved here. So you have this mass that is M1, then M2, then M3. Then a force capital F is applied on the system. So they are asking force between M1 and M2. I'll mark that as P. That is a force between M1 and M2. Okay, here as well you have to just apply F equals MA to the system and then to part of the system in order to find P. So if we think about the system, the whole system, these P forces cancels off. Those are internal forces. The only external force on the whole system is capital F. Then the mass of the system is M1, M2 plus M3. I'll say the acceleration of the system as simple A. Then simple A is equal to F divided by M1, M2, M3. Okay, now we found the acceleration of the system. What we need is to find the normal reaction, that is P. Okay, then I'm applying F equals MA to this part only, to this part. I'll say that part as M3 and M2. So on that part, the only external force applied is P. P is the only external force acting on M2, M3 system. So that is a part of the whole system, right? M3, M2. So the force is P, then the mass is M2 plus M3. The acceleration is the same acceleration. Then just substitute that acceleration here. So this is M2 plus M3. And the acceleration, if you substitute that F divided by M3. M3F divided by M1 plus M2 plus M3. So this is the normal reaction between M1 and M2. This P also is the same, right? Those are action-reaction forces. So the answer should be third one, right? Sorry, not third one, should be fourth one. M2 plus M3F, M1, M2, M3. So the answer should be fourth one.